do two more things. They're going to ask you where are the foci, or foci, whichever way you want to call it, and draw a graph of the thing. Okay, on your card, we just wrote a formula for how to find out to give the coordinates of the foci. What you have to know, are you doing a horizontal or a vertical? We're doing a vertical, so you should see on your card that your formula says take H and K, which are the center, and it says add some on to the y coordinate, which makes sense. This thing's vertical, so you're going to go up and down to get to each focus, so you need to add something onto the y coordinate. So in our case, the center was at 3, 5, but we need to add on C. Do we know C? Yeah, on your card you should have written C squared equals A squared minus B squared, and this is Y. You got to always find C. So in our case, A squared would be the 25, B squared is 4, and 25 minus 4 gives us a lovely 21. If I square root it, can I break down square root of 21? There's no perfect square numbers that break it, so we're stuck with square root of 21. So you will just put in here 5 plus or minus square root of 21. Usually C does not come out to a nice number. Once in a while you'll get C to be a nice number, but usually C is the square root of something. And we're just sort of stuck with it. You do not have to graph each focus, because they're usually not at nice numbers. You'd have to turn them to decimals to graph that. But I do want you to graph the ellipse, and actually after you've done all this, graphing the ellipse is PUD. You can write this part on your card if you so desire, how to graph it. All you have to do to graph it is plot the center, A, and B, and you'll have your ellipse. So in this case, our center was where? Center was at 3, 5, so I would go over 3, up 5. There's center. Okay, we know A is 5 and B is 2. So from the center, I've got to count 5 units one way and 2 units the other way. The question is which one goes which way. Should A be going sideways or should A be going up and down? Okay. It tells you A came from under Y. The big number was under Y, so you go up and down 5. Because Y coordinates go up and down. So we're going to go up 5 and down 5. And then B has to go the other direction, which was 2, so you're going to go left and right 2. And then, okay, my only request when you draw them is try not to end up with footballs. They shouldn't have pointy little ends. Try to at least round off. I don't draw perfect ellipses, but just don't make them pointy little footballs. That was starting to be pointy. Try to round them off, and we're fine. It's an ellipse. Boy, howdy, was that good fun. Okay, you don't have to complete the square on every problem, definitely. Completing the square is definitely the kicker to doing this. We'll comment come test time if I give you a problem where I have you complete the square, find all the parts, and graph it. They tend to be like 24-point problems. By the time you've done all the steps to complete the square, and then named me all those various parts, that's a lot of points. Needless to say, if you can't get your square to complete right, I will help you or tell you to fix it to something that is right and keep going. But that you do want, make sure you do a couple problems at least of completing the square, so you make sure you've got that down. We're going to do hyperbolas next class, so you complete the square the exact same way on a hyperbola. The only difference on a hyperbola is there's a subtraction in one spot instead of an addition, but otherwise hyperbolas work identical to this. Since I have the extra minutes, we could go back and add the one other thing we need to add. This is not something I personally get real excited about, but some mathematicians just think this is just the coolest thing ever. I remember I'd never seen a conic section until I was in college in calculus. I should have been taught them in high school, but I wasn't. And they talked about the eccentricity. It's a great word. Okay. Mostly we talked about eccentricity with ellipses. And eccentricity is simply is it a round ellipse or is it a flat ellipse? So if you're going to talk eccentricity, you're talking about how round or flat the ellipse is. To calculate eccentricity, the formula for eccentricity is C over A. That's it, C over A. On an ellipse, it'll always be a number between 0 and 1 when you calculate it. I'm going to call it E for eccentricity. I think it's easy to remember. The closer the number is to 0, it'll be some decimal. The closer it is to 0, the more like a circle it is. The closer it is to 1, the flatter it is. So it'll be more round if it's close to 0. It'll be more flat if it's a number close to 1. Sometimes mathematicians just want a quick estimate of how round or flat a ellipse is. The other conic sections have eccentricity, but we tend to not care as much. But I'm pretty sure I asked you to write them on your journal, so I'll list them here. Circles. Given this, what do you suppose a circle's eccentricity is? 0. Circles have an eccentricity of 0. The ellipses are between 0 and 1. Which shape do you think is when it equals 1? You got parabolas and hyperbolas left to choose from. It's parabolas. Parabolas have an eccentricity of 1. Hyperbolas, which we actually haven't learned yet, they have eccentricity turns out to be greater than 1. So you've heard it. It's a way to measure and tell what you have. I personally have not used it for much other than about one day of calculus to find eccentricity. But for ellipses, it's kind of handy to know, is it a round ellipse or a flat ellipse? But the rest of them, we don't use it all that much. But you've now heard it. There you go. Eccentricity. It's your new word of the day. Okay, so